project presentation of AI-driven financial insight platform. It's an intelligent system combining human expertise and AI analytics to support transparent investment decisions. Three user groups, investors, analysts, and engineers collaborate through feedback, helping the system learn and refine continuously for better financial insights. This use case diagram shows how users interact. Investors submit queries and view AI-generated insights. Analysts review and comment on results, and engineers maintain data and model performance. Together, they form a feedback loop where human judgment and AI reasoning improve each other. Here, the workflow starts with investors submitting queries. AI retrieves market data, analyzes it, and returns visual results. If needed, investors refine and resubmit, creating an iterative cycle of improvement. Our system design uses multiple models to ensure traceability and coherence in every interaction.
This slide shows how our system rules work together with the AI agents through ad hoc requirements. These diagrams outline how automation combines with human expertise, setting the foundation for our latest use cases. Each ad hoc process links the system key modules, such as data analysis, feedback, and validation, into one continuous workflow that supports traceable and reliable operations. This slide gives an overview of our system's three main roles and their core use cases. For the investor, the key tasks are requesting and viewing investment insights, and visualizing market trends and risk indicators. Investors can submit queries in natural language and instantly receive clear, data-driven results from AI agents. The professional analyst handles reviewing and annotating AI outputs and providing feedback for continuous model learning. Their comments and confidence scores help refine future AI suggestions and improve the system over time. The tech team is responsible for validating AI-generated reports and monitoring and retraining system performance. They check accuracy between AI agents when needed and keep the whole platform stable. Together, these three roles create a human-in-the-loop AI workflow, combining user interaction, expert feedback, and system maintenance into one integrated process.
Our intelligent finance system is designed using 4+1 architectural view model, which describes the system from the perspective of end users, developers, and the project manager. The logic will outline the system main functions, from data collection and pre-processing to AI-driven analysis and visualization, ensuring clear separation of concepts. The development views shows how the system is built, with independent layers for front-end, back-end, agent service, and databases, supporting modular and scalable development. The process will explain runtime behavior such as data streaming, agent coordination, and user requests, ensuring real-time performance and reliability. The physical view maps these components to our cloud development, highlighting scalability and fault tolerance. Finally, the scenario view connects all four perspectives through real user workflows, validating that the architecture meets both functional and non-functional goals. By adopting the 4+1 model, our system remains organized, maintainable, and user-centered.
Okay, this slide shows the class diagram of our system. It defines the key entities, their attributes, and the relationship between the user's agents, technical team, and the database. The investor and the professional analyst represent the two main user types. The orchestration agent acts as the core controller, coordinating sub-agents like the retro agent, analysis agent, and the visualization agent. Each agent performs as a specific role, retrieving, analyzing, or visualizing data, while all query and output records are stored into the repository class. This structure ensures a clear modularity and a supporting system to maintained by the technical team. Next is the object diagram. It demonstrates a runtime snapshot of the system. Here we can see how specific instances such as the investor Alice and the analyst Dr. Jackie interact through the orchestration agent. When the investor sends a query, the orchestration agent triggers the retrieval and the analysis process. producing an output log object stored into the repository. This diagram reflects how the class relationships are realizing during the system execution. And the collaboration diagram, it focuses on the message flow among these objects. Each numbered arrow represents a message of function called in sequence. For example, some query, fetch market data, raw indicator, and still output. The investor initiates the process, and the agents collaborate step by step to fetch external data, compute indicators, and generate results. It also includes interaction for analysts reviewing outputs and the technical team to maintain actions. Overall, this diagram visualizes how different components communicate dynamically to complete the workflow. And finally, the structured class diagram shows the internal composition of the system and its connection to external interface. The coordinator, which is an orchestration agent, manages communication through different ports: the investor port, analyst port, external API, and the maintenance team ports. Inside the system, components like the retrieval agent, analysis agent, visualization agent, and the repository interact through the labeled connectors, such as the fetching data or saving data. This diagram highlights the system's modular and maintainable design, where each agent is independent but interacts seamlessly within the overall architecture. Together, these four diagrams demonstrate how our system is designed, instantiated, and operates dynamically. Next, Gary will continue with the presentation, focusing on the implementation details and the system evaluation.
Hi, I'm Zirong. This slide shows the behavior modeling of our finance AI agent system, describing how it acts and reacts over time. The activity diagram shows the overall workflow between the user, AI agent, and backend. The sequence diagram explains how components communicate step by step through API calls. And the state machine diagrams tracks how an AI output moves from creation to review and validation. Together, these diagrams ensure our logic, timing, and lifecycle behaviors are consistent and reliable. Next, in structural modeling, the package diagram organizes the system into clear modules: the React front end, Spring Boot backend, AI agent layer, and databases, showing dependencies through RESTful interfaces and maintaining a clear architecture. Finally, the deployment diagrams demonstrate how the entire design runs in the real world, mapping all components to servers and external APIs such as OpenAI. Overall, these behaviors and structural models links design and deployment, ensuring the system operates smoothly and reliably.